Hi students, hello. This is Saranya, Assistant Professor, Department of Mathematics, Dr. MJR Educational Research Institute. The part one we have to discuss about the introduction, application, important of Fourier series, periodic function, sine and cosine graph, Dirichlet condition, Fourier series, Euler's formula, definition of Fourier series, and up to till we have the problem based on 0 to pi. Now we are going to discuss about the part 2 video, Fourier series even or odd function, problem based on minus pi comma pi. Now let us move on the directly a problem even or odd function Fourier series. Even function and odd function f of x is said to be even now. F of minus x equal to, you have to getting the f of x positive f of x. If it is an odd function now, f of x is an odd function now, f of minus x is equal to minus of f of x. This is your even and odd function. We make use even function. If even function Fourier cosine series, f of x is a even function with period 2 pi, defined a minus pi comma plus pi, then f of x can be expanded in a Fourier cosine series. Fourier cosine series means you have to take f of x, so you have to even function now, you can solve a naught and a n. F of x is equal to a naught by 2 summation n is equal to 1 to infinity a n cos n x. The Fourier coefficient a naught a n calculating by the Euler's formula. This is a Euler's formula. Z a naught 2 by pi integral 0 to pi f of x dx, a n 2 by pi integral 0 to pi f of x cos n x dx, and odd function of Fourier sine series. F of x is odd with function with period 2 pi, defined minus pi comma plus pi. Then f of x can be expanded as a Fourier sine series. F of x is equal to summation n is equal to 1 to infinity bn sin nx, where the Fourier coefficient bn is calculated 2 by pi integral 0 to pi f of x sin nx dx. Problem based on minus pi and pi, minus pi comma plus pi. To find the Fourier series, f of x equal to mod of cos x in interval minus pi comma plus pi. First we have to check whether it is even or odd function. F of minus x is equal to f of x. F of x is equal to, you have to put minus sign. The given function is an even function, then bn is equal to 0. You have to find only a naught and a n. The series of Fourier series, f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos nx. Fourier coefficient a naught and a n. Uh, mm, now, now we find a naught. A naught equal to 2 by pi integral 0 to pi f of x dx. F of x is given function mod of cos x. So this interval we have to make it split into the two parts. One is a 0 to pi, 0 to pi. In between you have to take it as a pi by 2. Okay, it's a modulus. So you take this interval 0 to pi by 2 and pi by 2 to pi. You have to make use this interval splitting into the two parts. So mod only will be there. Mod you have to split, one is a positive, another one is a negative. This is a positive. 0 to pi by 2 will become positive. Pi by 2 to pi will become a cos value function. F of x value will become a negative. In the 1 by a naught is equal to 2 by pi cos of 0 to pi by 2 cos x dx plus mod x. You have to written like this: 0, 2 by pi integral pi by 2 to pi minus cos x dx. Now you have to integrate these one, simplify cos x. You have to integrate, you have to getting a sin x. Again here you have a cos x sin x. The limit will be changes. Upper limit sin pi by 2 value will become 1, sin 0 0, sin pi 0, sin pi by 2 value will become 1. So 1 of 1, 1 plus 1, 1 of minus 1 equal to 2. 2 by pi 2 into 2 by pi, which is equal to 4 by 5. This is a naught. A naught is equal to 4 by pi. Next to find an is equal to 2 by a pi 0 to pi f of x cos nx. F of x, you know about the cos mod of cos x, mod of cos x, you have to split like this. 0 to pi by 2, limit will be splitting into two parts. 0 to pi, 0 pi by 2, pi to pi by 2. So cos x, positive cos x sin nx, minus negative cos x, uh, cos nx. Cos a cos b formula we have to apply. What cos a cos b formula? Cos a plus b plus cos a minus b. Here also cos a cos b, a plus b cos a minus b. After applying the cos a cos b formula, now you have to take integrate. So you have to getting a sine of n plus 1 of x equal to n plus 1, sine of n minus 1 of x divided by n minus 1, 0 to pi by 2, sine of n plus 1 of x by n plus 1 minus sine n minus 1 of minus 1 of x pi by 2 to pi. First we have to apply the upper limit and then lower both the case, both that both you have to apply upper limit of minus lower limit. Here also upper limit minus lower limit. After you getting this one, you have to getting that how do you getting this now? Sine of cos of n plus pi by 2, cos n pi by 2 value will become cos n pi by 2. This is also cos n pi by 2, cos n pi by 2, cos n pi by 2. Here numerator will become change n plus 1, n minus 1, n plus 1, n minus 1. See here cos of n plus 1 pi by 2. How to return cos of n plus 1, the sine of n plus 1 pi by 2? How can you return? You have to return a cos n pi by 2. Sine of n minus 1 pi by 2, you have to return minus cos n pi by 2. This one you have to return like this. Then after that, you can simplify this. You have to getting this one. Then after that you have to simplify. You can take the both LCM. You will getting the numerator n square minus 1 minus 2, and then 4 pi n cos of n pi by 2 minus 1 upon n square minus 1. This 2 take it outside, it will be multiple of the 2. The final answer is 4 pi pi minus 1 upon n square minus 1 cos of n pi by 2. N is not equal to 1. So then next a1 you can find. So a1 equal to 0 to pi by 2 into pi by 2 to 1 cos x cos x cos. So you are getting a cos square x you have to written like this 1 plus cos 2x. After applying the trigonometry formula cos square x formula, then you can take integrate. So integrate and then apply the int integrated. Then after you have to apply the limit, you will getting the 0. So what you get, integral 2 by n is not equal to 1. First a naught by 2, a naught by 2, 2 by 5 plus summation b1 a1 cos x, that will become a 0 a1 value. Then that's why the series is start from 2 comma 4 to 4 infinity. It start from a even number. So finally you have to write a minus 4 upon pi of n square minus 1 cos n pi by 2 in cos nx. Conclusion of a Fourier series. Fourier series is a powerful mathematical tool that decomposes of a complex period function into a similar trigonometric component. This concept is formed the foundation for advanced topics such as the Fourier transform and is essential model science and engineering. Thank you. Now this over, part 2 is over. Thank you.